Good evening, everybody. We will be going live by 3:20. This is just the testing that is going on. This is just for testing. We have just joined earlier a bit, 15-20 minutes earlier. So we will be doing our testing, usual, to check. We will be live on YouTube also. That I'll be sharing the link on the. I'll just put. So if you find it difficult, so I have put the YouTube link also. If you're unable to join through Zoom link, we'll be there live on YouTube also. You can check it through the YouTube, through your YouTube link also. So this is just an preliminary testing that's going on. So you can join later on the Zoom as well as on YouTube. Rehab madam, can you just check whether we are live on YouTube? Rehab ma'am, can you just check it whether we are live on YouTube? Just for a confirmation. Yeah, we are live on YouTube. I'd like to inform you all that we are live on YouTube also. Welcome, Dr. Siddharth Desai, Mr. Pawar, Rajaya, Satish, Mr. Karthik. Welcome you all for this webinar. And glad to inform that today is Dr. Prashant Kharkar's birthday also. You can share this YouTube link with your friends because first 100 participants can join live on Zoom, and rest of them you can share this link. So we will be live on YouTube also. So those are unable to join the Zoom link can join us on YouTube also to listen to the speaker. Thank you. Welcome, Pallavi. Welcome, Dr. Sonakini. I have shared the YouTube link also in the group, in the chat box. So those who are unable to join us live on YouTube can log in. You can share this link with the friends who can also join this session on YouTube also. The first 100 participants will be live with us on Zoom, and rest of them can join us in YouTube. We can share this link with the people so that maximum people can participate in the webinar. Thank you. Welcome, Bina, madam. The speaker will be joining us around 3:20 because the schedule is 3:30. The speaker will be joining us around 3:20. Welcome, Dr. Gautam Shenai from Manipal College of Pharmacy. I warmly welcome my guide, Sonakini ma'am, and Gautam Shenai sir from Manipal College of Pharmacy. Thank you, ma'am, for coming.
Hello, Pramod.
Yeah. Hello, ma'am.
Yeah. 3:20, he'll be joining.
Yeah. Because this was we have just before to check whether everything is right.
Oh, okay.
Yeah, and glad to inform you that our college got selected for NSS UNICEF program this time. We were one
I
of
see.
colleges, 40 colleges from RGHS got selected for NSS UNICEF program on malnutrition.
You are the NSS officer?
Yes, ma'am.
I see. Okay.
Yeah, because Aloka, since we are doing
Yeah.
this, uh, I'll be trying to do this also program.
I see. Okay. So all this Aloka, whatever you're organizing comes under that, or this is separate?
No, it's completely different. It's complete. We are completely different. It's different from that is different. This is our own foundation that we are working on. That will be different. That will be college.
Okay.
We plan to go to villages as per the instructions from the UNICEF coordinators who had trained us for 3 days. So we will be doing camps, rallies during this period.
Okay.
So that was a opportunity. 3 days program we had, NSS training program for the program coordinators in Bangalore. I reached today morning from Bangalore.
Okay.
So I'll request the speaker to come a little bit early. I just call, and today is his birthday.
Okay.
And he works.
How do you know him?
He's Dr. Prashant Kharkar. He worked with me in Piramal Life Sciences, and he's an alumni of UDCT, and now he's a professor in UDCT also now.
Yeah.
Natunga.
I know. So he left Piramal, is it?
No, we all left. We had to leave because it got closed. We didn't want to leave Piramal, but since in 2014, the R&D unit got closed. Yeah. Though now that, but still we are in touch with each other, and he agreed to be a part of it for organization. He was our chief guest for our opening.
Oh, is it?
Yeah. So he accepted our invitation to deliver a webinar on the topic that is machine learning in pharmaceutical sciences, that is artificial intelligence.
Yeah.
Getting a call. And Neeta, I'll be sharing the slides. Okay. I'll be making you the co-host.
Yes, sir.
Neeta, I made you the co-host. Okay.
Yes, sir.
I'll be sharing the slides for you. Okay. We have shared the YouTube link also. So those are unable to join on your Zoom, your friends, or you can share that YouTube link, which is shared in the chat box. I request all the participants to join by their name so that please log in by your name. Please log in by your name. Don't put any numbers or something. Please log in by your name. You can rename yourself. So I request all the participants to join by their name. We have kept the options open for renaming yourself. I'll be sharing some videos of our Anuka Foundations, what work we have done till the time our judge joins. I'll try to share some. Danya, I made you the co-host and I'll be sharing the screen. Okay. Welcome, Sridevi Krishnan. I think our last week's speaker on intellectual property rights. Welcome, Sridevi, for this session too.
Thanks, Pramod. Just I was eager, really waiting. I thought it was 3:30, so I got late. So sorry.
No. We will be. It's just before half an hour before we just activate our link so that people can join as and when before the session. Our speaker will be joining in next few minutes as informed. Thank you. Glad to inform that 32 participants have already joined. Welcome, Dr. Prashant Kharkar, our today's speaker. Welcome, Prashant, for this webinar session. And before that, I'd like to wish you many happy returns of the day on your birthday.
Thank you so much. Thank you so much. It's just a coincidence, actually. Nice coincidence. Am I audible?
Yeah.
Okay, perfect.
So I would request, I'll just share the screen about the today's presentation. I request Neeta to take over. Is the screen visible to all?
Yes.
Yes, sir.
I'll make Prashant also the co-host, Dr. Prashant also the co-host.
Yes.
Just a minute, so that he can also share the minute. Just escape. Just make so that, yeah. So I've made Prashant sir as the co-host so that you can share your PPT, sir.
Okay, perfect. Thank you.
Thank you. I would like to request Danya to start with this session. Neeta.
Yes, sir. Before we start, I request everyone to keep yourself on mute. Good evening, everyone. I, Ms. Neeta, welcome you all today to the second webinar conducted by Aluka Foundation, Mangalore. I welcome all the participants to this virtual webinar series on today's topic of discussion, machine learning application in pharmaceutical sciences. I also feel honored to welcome the founder members of Aluka Foundation, whose support and blessings make every event successful. Our President, Professor Pramod Bhaskar Kumar, Secretary, Mrs. Rehab Thonse, and Treasurer, Mrs. Kantani Pramod Kumar, to this event. Before we introduce our guest speaker of the evening, let me take this opportunity to walk you through the journey of our foundation so far. Aloka Foundation came into existence on 6th September 2021, including a group of enthusiasts under the guidance of Mr. Pramod Kumar. The main aim of this foundation is to help not only people in need but also animals and the environment. From a team of just 15 members in the beginning, our organization has now grown into a team of 60 plus members and many volunteers from different states across. We started conducting various events and drives for the betterment of the society and are proud to say that we have coordinated with some of the most esteemed institutions across Mangalore for conducting health awareness drives and fundraising events. We have also coordinated with the Animal Care Trust Mangalore during pet adoption drives and donated essentials to the sheltered animals. Our team have conducted various donation drives in organizations across Mangalore like Snehalia Trust, Sevashrama, Kapila Gaushala, and many more. Our members conducted plantation drive across Mangalore on the occasion of World Earth Day. Not only that, in this digital age, we have managed to make way into people's social feed by giving daily updates about the various important days and various awareness videos throughout the time of pandemic and continue to do so. We believe that this is just the beginning as we have many more people to help and many more dreams to achieve to make the society a better place to live. Intro to the guest of honor. Introducing the guest speaker is a great honor in itself. Two distinct features of an achieving person besides hard work and perseverance is pioneering spirit and the willingness to do the unthinkable. Our guest of honor and speaker today is the living idiom of the same. I am pleased to welcome Dr. Prashant Kakar to today's webinar. He is a PhD Tech, Pharmaceutical Chemistry and M.Pharm Science, Pharmaceutical Chemistry from University of Mumbai, Institute of Chemical Technology, Pharmaceutical Division, Mumbai. He is currently working as a professor in the Institute of Chemical Technology, ICT, Mumbai, an esteemed institution in India. He has published more than 60 research papers in reputed international journals and has presented more than 40 abstracts in conferences of international repute, such as the Gordon Research Conferences, ACS meetings, etc. He has received prestigious international awards and is also the member of national and international studies. Now, without any further delay, I request our speaker to take over the session. Thank you.
Thank you so much for kind introduction. Am I audible?
Yes, you are audible.
Okay, perfect. I will share the screen. Is it visible?
The sides are visible, sir.
Okay, perfect. I'll just put it on the presentation. Okay, so a very good afternoon to everyone. A friend of mine just a few minutes ago asked me, who takes lecture at this particular time, Sunday afternoon, where everybody is in the relaxing mood and most likely fast asleep after a week's hard work or so. But then I just told her, in fact, she is part of this meeting as well, Dr. Veena Belgamwar from Nagpur. So I was telling her that this is the this is the time where I mean the participants would be only those who are really interested in listening to someone on some very interesting topic, and that way, instead of just numbers, I think the quality of participants who are really interested in understanding the subject, that makes the whole activity much more fruitful. And first, at the outset, I'm very much thankful to all the participants and, of course, the organizers, including Pramod and his team. I have been following Aloka Foundation right from the day it was inaugurated or it was started. I was part of that function, and then the kind of activities which are happening, believe me, it is very, very commendable. And the student support which Pramod and his team are getting, I think that's really amazing. And these students who will who will, after their graduation, when they go and go for their additional, higher studies, or they're pursuing their professional careers, believe me, they'll just spread this message. So in a way, this is such a noble activity. And when Pramod asked me, I was like, why not? And another friend of mine, Dr. Sridevi Krishnan, who was the first speaker, she's also present. She just wished me happy birthday. Thank you so much, Sridevi. And good to, I couldn't attend your webinar, but of course, I told Pramod that if I could have the recording. So without much delay, I would start discussing about this very, very important topic. And since many participants, they are either the faculty members or some independent professionals, including industry, as well as most of you being undergraduate students or PG students. So, the topic is of general interest, and everybody must get acquainted with this very topic, that is machine learning applications. Now, of course, many of us are from pharmacy or pharmaceutical sciences, so I just tried to curtail the application side on the pharmaceutical sciences side. Again, that too, when we talk of pharmaceutical sciences, it is so huge, but then I'm just going to talk about mostly related to drug discovery and drug repurposing. In fact, just before I logged in, I was going through my LinkedIn posts, and I saw one very interesting post where AI and machine learning helped in designing PET hydrolysis. That is the 12% of all the solid waste which is generated is basically polyethylene terephthalate, that is PET. And there is a group of enzymes which essentially hydrolyze this, so depolymerize PET, and then this can be further used for repolymerization and valorization. So that was a very interesting post. I thought I would get a part of it, but then you can probably just it was published in Nature. Believe me, that paper was published in Nature, one of the most cited or highly highly appreciated journal. So it's actually a pride. So they have used AI and machine learning approaches for designing the PET hydrolysis, and that's very, very interesting application. But of course, citing that example would be a little complicated for many of you to understand, because some of you may not be aware of what machine learning is, and that's exactly why I thought I would just use this opportunity to touch base the topic, that is machine learning, and this is exactly what I'm going to do. Of course, machine learning itself is such a vast field, and the kind of applications where this field has in a way entered, that is countless. In fact, AI and machine learning, we are using for daily daily activities as well. Whenever we use Google Map, whenever we use whenever we are surfing, whenever we order something, we see those advertisements popping up, and then some of those things are really of interest to us, right? So the system knows what we are doing and what we are liking, where we are going, how we are spending, everything. It's all machine learning. And then even the traffic, like I said, Google Map, how does it know exactly that it will take 32 minutes to reach to the city center, right? So, and again, it gives you the shortest possible route. How does it know? I mean, computationally, it is a very exhaustive thing if you have to take into consideration everything that is possible. But then this algorithm tells you in lowest possible amount of time and lowest possible distance that you travel to reach to your destination. It's all machine learning and AI. It's everywhere. It's just that we are not really seeing it, or maybe we are not really aware of it. And that's why I thought I would talk about it. And this is where I am. I have already thanked the organizers and all the student members, participants, and whosoever is present here. Thank you for being here and spending your Sunday afternoon for listening to what I have.
I request everybody to mute yourself. Please don't disturb the speaker in between. Thank you.
Okay, thank you so much. Okay. So my first question is, what is machine learning, right? Now, as far as machine learning goes, it's not something that we don't know about. I mean, those who have used Excel for calibration of some pharmaceutical standard, maybe for some analytical method development, HPLC, UV. So we develop a machine learning model, or rather a model, I would say, an equation y equal to mx plus c. So we take 6 to 8 concentrations, and then we record the absorbance, or we record the area under the curve or area under the peak, and then we plot it against the concentration, and then from that we try and find out the unknown concentration. So in a way, and the equation which we use, the standard curve or calibration curve equation which we use, where we check r square is equal to 0.9999, and then so that tells us that whatever concentration of the unknown that we are going to find out is going to be much more accurate. And then we also see that that's a straight line. So in a way, that y equal to mx plus c is actually a machine learning model. I mean, that is the simplest form of a model, a machine learning model. So in a way, that's what I was saying, that when you say machine learning, it's not something that we don't know about. So typically when I say machine learning, so I'm referring it to a model equation, which will help me in achieving the objective with which I started off with. So then again, talking about the same question, like what is machine learning, and then the equation or the model. So for developing that model, I need data, right? So I have that data, 6 to 8 concentration, known concentration, then I record the absorbance or area under the curve or area under the peak area, and then I use that data to develop the model, and then I use that model for calculating or predicting what I'm interested in. So in very layman's term, machine learning is a tool by which you achieve the objective which you would want to use, and that's where at the center of machine learning you have a model. Now, for developing that model, you need to first generate the data. So data generation is an important or integral process, and then the next part is to use an algorithm which will use the data to develop the model. And of course, the same algorithm will help you in predicting what you are interested in, or in telling you something that you are interested in. It could be weather prediction, it could be finding the simplest route to reach to a destination, right? So everything is kind of intertwined, and as we discuss further, you will know where machine learning stands, what is deep learning, what is AI, and how these are related with each other, and what is the context. Although many of the, the boundaries are not really distinct, they are into each other, I would say very hazy boundaries, but then for all practical purposes. So we have limited machine learning to a tool which will give you a model, and that model can be used for the purpose we are interested in, right? So okay, so understanding the machine learning. Okay, so now here what I'm showing you is, before I actually talk about machine learning, although I have already talked about machine learning a bit, but here this is one very interesting book. I would those who are interested in machine learning, this is one very it's an e-book actually, not very long, probably less than 100 pages. It's a machine learning dummies. It's brought to you by IBM, and this is the website. You can download it and then just get to know what machine learning is. So you can see from the cover, it says understand machine learning fundamentals, the very basics of machine learning, make sense of machine learning algorithms, because they are at the core of machine learning tools or machine learning as a process, and build your own data science team, right? So because when you talk about AI, machine learning, deep learning, everything revolves around data. So there is a separate discipline called data science, which deals with data generation, data treatment, data storage, and usage of data for as an input for many of these tools. So data science again is interspersed with machine learning, deep learning, as well as AI, and this is exactly what we are going to talk about. So coming to the most important part as far as what is machine, answering the question, what is machine learning? So here, machine learning allows you to continually learn from data and predict the future. Now, this is what I told you at the beginning, at the outset. You need data, and then this machine learning algorithm will try and make sense out of this data, and it will learn from that data. So you provide a higher amount of data to the machine learning algorithm, and it will in a way learn better, right? So this is where the utilities, and then of course, I mean, you just don't want to generate data and use this machine learning algorithm to not for just for the fun part of it. Of course not. You want to predict the future, and that's what we are most interested in now. When I say predict the future, I'm not saying when I'm going to die or when something is likely to happen. It is just that predict the future, meaning predicting the future events. Like I have, say I have a company, and this is my manufacturing statistics or data related to manufacturing, and based on the people's behavior, can the machine learning algorithm predict how much will be demand for my products? It could be an apparel, it could be shoes, it could be anything. Right, so the machine learning can actually tell you that how you should be adjusting your manufacturing capabilities to meet the demands. So if the machine algorithm tells me that, okay, in October, you are going to have a great demand for a certain type of apparel, right? So in that case, if you know this in March, obviously you will put things together and make sure that by October you will scale up the production capabilities and make sure that whatever demand the market has for your product, and you make a lot of profit. So everything boils down to making profit, but then the machine learning algorithms, by predicting future events, tells you that be ready, this is coming. Right. So of course, there are other techniques as well, forecasting, which is in a way a machine learning related technique, and though they typically use forecasting in stock market. But here, I don't want to get into that. But ultimately, what I'm trying to tell you is, you have data, you have algorithm, and you develop the model and use that model for predicting future events, right? So, what is at the heart of machine learning? You have got a powerful set of algorithms and models, right? And these are continuously evolving. It's not like you make a machine and then you hope that it will keep on working for like next 10 years or so. Of course not. You will have a better machine. I mean, you look at cars. Every new version is an upgrade over the previous version. Some people are talking about hydrogen fuel cell in the car instead of gas, or even for that matter, the gasoline or petrol. Right, so it's an upgraded version, and which is far more safer in terms of environment and other things. Right? And even economically, it is also very powerful. Powerful in the sense, economically also it is very I would say very cheap, right? So here, this is exactly the same philosophy is used. So these algorithms are continuously evolving, and this is where the predictive capability or prediction capability of these algorithms goes on increasing. I mean, we always joke about Indian meteorological system, where we talk about, oh, they say that today it will not rain, but then it will on the same day it will rain, and then we make a joke out of it. But believe me, nowadays that's not the case anymore. I mean, if you are in US or Europe, it will give you the predictions every minute, every hour. What is going to be the wind chill? Whether it is going to rain for how long? How do they know? It's all because of these very powerful machine learning algorithms, right? So, and the models which continuously learns from data and eventually tells you that this is going to happen. You don't use this particular route, you are going to stuck. You rather use another route, or if you are lost somewhere, it will tell you that okay, now you are lost, so you have to reroute yourself, and it will guide you to reach to your destination, meaning fulfill your objective, right? And then at the same time, when I say it learns, the model learns, then in that case, it is just trying to give you insights into the patterns, meaning how the market demand is going to go up or down based on the other factors. It could be, of course, I'm not talking about pandemic where everything collapsed, but then based on the routine analysis of the data throughout the year about a particular activity, it could be sales of a particular commodity or the revenue generated by a company or so. So these, so there are patterns, and then you can learn about these patterns from humongous data. I mean, just give you Walmart, right? Walmart is present in more than probably 100 countries or so, and then there are so many stores. So for every store, and then at any given point of time, probably 100 customers are buying something, they are paying the bill. You can imagine 100 countries, then probably 100 stores in one country, and so that becomes 10,000 stores, right? And then 100 customers at the same time, and that too, there are a lot of every customer is buying, say, on an average 20 different things. You can imagine the number of transactions which are generated at every second or maybe in a day. That is humongous. So then how do they actually keep track of that and learn from all the transactions? I mean, there is something called as market basket analysis. Many a times in advertisement, you see that you see an advertisement of a soap, and then they'll give you a pen free. How do they come up with those weird combinations? Or when you go to a supermarket, when you see that something is kept next to something, and it doesn't, there is no, I mean, you probably don't think of any connection there. So again, that is, they analyze these transaction data, and from that they actually do something called as market basket analysis, and that's how they will arrange the items in the store to optimally increase the sales, right? So by to understand the patterns in consumer behavior, and there is so much. And in fact, the bank frauds, they are also detected by machine learning algorithms or anomalies within the data. And this is exactly, I mean, there are lots and lots of applications. You can even detect what type of disease a plant has got. I attended one machine learning algorithm, or rather training, in IIM Bangalore in 2015. So then one of the guys, they developed a deep learning tool, and then for farmers in rural areas. So all the farmer has to do is take a picture of that, and that algorithm will tell whether what kind of disease it is, and it will also tell what is the right combination of insecticide or whatever it is to be used with minimal damage to the farmer's health. So the possibilities are enormous, and we can't even think of what is possible with these. And that's exactly why I thought I would make you guys aware, if you are not aware of what machine learning is, and then focus on the pharmaceutical application. But then, like I said, the data is continuously generated, and now not that what data you generate this year or this time of the year will be same next year. Absolutely not. And that's why machine learning is a continuous process, meaning the fashion trends which you have this year may not really be the same next year. So if a company has to decide what apparel to make and all, so they have to actually learn from that data, and based on that, they need to move ahead. right? So it's a continuous process, and on an average, the life of one machine learning model is around 4 months, and then after 4 months, new data is available, and that data is used for further refining the model to adjust for the factors which are not under control of the person, right? Under control of the person. Right, and this is exactly the whole premise of machine learning is you have data, you have algorithms, the data keep changing, you keep on changing the model and use the model for understanding the pattern, to understand what is possible, to understand what is future, like what are going to be the future, and you be ready to face the future, so that you increase profit, you minimize losses, and you do what you optimally use the resources. And that's what machine learning is all about. So talking about machine learning and its connection to artificial intelligence. So this is the overall scenario. So artificial intelligence is a bigger picture, meaning it is at the base of everything, right? And then one part of artificial intelligence is machine learning. Of course, when you talk about artificial intelligence, you might have seen this advertisement. So this family is flying to some destination in the plane, and then this guy asks whether you have switched off the AC or not, and then this kid says that no, my teddy is there, so he has to. Of course, the advertisement is about the fridge, but then there is something called as IoT, right? So with the help of IoT, no matter where you are, you can actually operate the instruments in your company. Internet of Things, IoT is Internet of Things. So with the help of internet, you can switch off a machine, just by sitting at home, and the factory could be somewhere remote in the country or so, right? So all of these things are possible, but then that's the bigger picture. That's what I told you. So when you talk of artificial intelligence, so that's more complicated or more complex, and so are the applications also exhaustive. So you have got reasoning, natural language processing, and planning. So text to voice, that conversion, and then even from the pictures, you understand what it is. Right, so many times you log in some website, and it will ask you, it will try and identify whether you are a human being or something else, right? So then there will be a number given and some line will be there, but it's just trying to test you. And that is because the computers, they are probably the dumbest ones. They don't really understand, meaning the spam activities they would want to prevent. And that's where they're using these tools. Of course, so what I'm trying to tell you is there are tools. A very interesting example before I get into the real topic. A few years ago, they started. Now, this was actually in the USPS, that is US Department of Postal Service, United States Postal Service. So they receive, lots and lots of mail, and then they, manually sorting those is real trouble. So they started developing a deep learning model to identify the pin codes, right? The area codes, so 41610. Now, if now there are 7 billion, 7.5 billion people on Earth, right? And say out of it, say 400 million are in US. So every person can write the digits. Now it's a combination of 5 digits, right? 41216. So I can write 4 some other way. Somebody else can write 4 some other way, or even 8, 9. So they developed a model, and they really had to put in a lot of efforts to identify a particular digit. There are only 9 digits, like 0 to 10 digits, 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 8, 9, and then 5 combinations. So they had to really put in so much effort to develop a model to identify that number correctly, right? So because of that, now it is very easy for the mail to get sorted, and it's very, very fast process. So they're using machine learning tools for this particular aspect, right? So, so machine learning, like I said, it comes under the ambit of artificial intelligence, but it is just small part of it. And you talk about deep learning. So deep learning is one small part of machine learning. I'll tell you what deep learning is. Now, when you say deep learning, you're talking about artificial neural networks. So, so then you have got an input layer, you have got an output layer, and you have got hidden layers. So even those who have actually discovered neural network, they don't know what goes on in the hidden layer, but based on what data you supply, you get the output, and then the output or the predictions are extremely good. And this is where deep learning has come up in a very big way. I told you about this IIM guy who has developed a deep learning tool for identifying the diseases just from the image. So image processing is one aspect of so-called deep learning, which again comes under the machine learning, which is part of artificial learning. So they are all intertwined. But then even if you say you want to learn machine learning, probably that's easy. But when you talk about artificial intelligence, that's a little complicated in a way because algorithms are a little complicated, right? So, but then coding is one important aspect, and nowadays most of the ML tools they either use R as the language or Python. I am a special fan of Python, special as in I like Python more than R. I have learned R a bit, but then Python is much easier if you ask me that way. You see, it's a fourth generation language. So you're writing the program as if you're writing a letter or you're writing a statement. And then in the background, that statement gets converted into a complex code, and then the whole task is executed. So you're writing a code which is like this small, but then that small code will process a real huge data without you even knowing it, right? I mean, how it is doing and all. So I mean, it's very interesting, and the more you learn about it, the better you get at it, right? And then you develop more interest. And particularly for students, if you don't learn it now, maybe 5 years down the line, you will be forced to learn about it. So why not start today and get into something where you can actually have these unique capabilities of so-called developing machine learning models. And like I said, the applications are enormous, and there's no way you can actually limit yourself in expanding the horizon, right? So coming to approaches to machine learning, so first and the foremost, or other more important, more commonly used is supervised learning, where you have got a dependent variable which is y, you have got an independent variable which is x, and the equation y equal to mx plus c, where you know what y is, where you know what x is, you know what the values of x are, you know what the values of y are, and then you try and develop a relationship between them and try and predict the value of y based on the value of x, right? So that is supervised learning. So you know about the data labels, you know whether it is a categorical variable or a continuous variable or a binary variable. When I say variable, that means a quantity which changes, which has got, it could be, it could have values like 0, 1, it could have values like tall, short, medium, heighted or so, or it could be, it could also have values like any value between say 1 to 10,000, right? So depending on that, the variables are classified into several categories, and based on what is the type of your variable, your selection or choice of algorithm, it differs, and that's why you need to understand the data and the data structure, right? So supervised learning, it begins with an established set of data, and then a certain understanding of how the data is classified, and then you are trying to find out the relationship between the variables and use that relationship or model or equation for predicting the value of y, which we call as dependent variable, right? So somebody has developed an ML application which distinguishes one fruit from the other. It's like you've got a big supermarket, and then all the fruits, they need to be kind of classified or segregated. And this is where somebody actually developed that application. So a camera will take a picture and it will identify it is an apple or a peach or a dragon fruit or so. And somebody actually developed a very interesting thing. On LinkedIn, many times you will see somebody is saying something on the screen, and then that algorithm will identify the emotion, whether it is happy or sad or kind of other emotions. So those are very interesting applications. Another example is weather forecasting. So now for weather, there are high-end instruments available which will record which will take the readings at different parts, and then the Doppler, which will basically keep on scanning what is happening, whether there are the clouds are coming or rains are likely to happen, and also using that data, it can forecast what is going to happen. I mean, if you go to US or so, we don't use weather that way here. That I mean, we all know it's not that bad. But then in US, they have to, meaning other parts of the developed world, they need to know whether it is going to snow, how long, and then whether the weather is really going to go bad, or so that weather forecasting. So many applications are there. So all you do is you're training an algorithm using a pre-processed data or examples, and then you try and predict the future events or some quantity. And of course, the quality of the prediction by that algorithm is evaluated using test data. So you have a training data, you develop the model, and then you test the ability of that model to predict using a data which is not seen by the model while it was getting trained. So you're testing, you're challenging the model for its prediction ability, and if the model is really good, it will try and predict the value of the test data the way it would be like you are expecting. So the difference between the expected and the actual, smaller is the distance, or smaller is the difference. Basically, the model quality is good, and that's how the model quality assessment is an integral part of machine learning. There is another type, that is unsupervised learning, which basically deals with the unstructured data or unlabeled data. I mean, look at your Twitter data or WhatsApp data. Of course, they say that WhatsApp, it's all kind of encrypted data. Nobody else, even the WhatsApp, cannot see it. But then, say talk about the Twitter, it's in the open, or Instagram data. So in fact, the US presidential elections, or even Indian prime ministerial elections, like Indian elections, state elections, or national elections, people, these algorithms try and predict the sentiments, and those keywords are used in the speech of the leaders, in the speeches of the leaders, and that's exactly how you kind of convert the voters to get into giving you the vote. So that has been tried when Obama became the president for the first time, right, long ago, and then it is being tried everywhere. In fact, I know a very good machine or deep learning scientist. So he was in UP for last 6 months just before this elections happened. And then he did help a lot of leaders there for modifying their speech using those keywords. And this is exactly what this is a word map. So you collect the Twitter data, and you analyze the sentiments. So higher is the letter size. That means more important that particular thing is, right. So this one is the word map for during the pandemic. Whatever people were talking, or whatever literature was getting published. So some word map like this can be generated. In fact, you can also do that using Microsoft Word. You take a document and you analyze for the word map, and it will give you the important concepts in that particular document. So this is what I'm talking about, unstructured data. So some people are posting images, some people are talking, meaning audio files are there, video files are there, the text is there, right? So it's an unstructured data, scrambled data, and this is what is analyzed using so-called unsupervised learning algorithms. And that's exactly what even Snapchat, Instagram, all this data is analyzed, and then this data is analyzed without human intervention. That data is used for predicting some, or finding some patterns, and then use that pattern. So unsupervised learning is also a very powerful tool, because most of the times the data is coming from various sources, and that's where you really need to have a capability to actually work around that data. There is another one, reinforcement learning. It's like how the child learns. If you tell if you teach the child to
one.
Yeah, I've done it. I muted the person. Person carry on.
Okay, so now here the reinforcement learning is like the way child learns. Like you teach the child, say mama, say papa, like that. So that's how the child will see, it will learn from how you teach. So that's exactly what the reinforcement learning is all about, behavioral learning algorithm. So you don't really start with the data. The algorithm will receive feedback from the analysis. So if you teach the algorithm that this is how the happy face is, then it will learn, and then it will remember that instance and use that for future instances. So whenever it sees somebody smiling, it will say happy, it will predict happy. So it receives the feedback from the analysis of the data. The user is guided to the best outcome. In the next and then, like I said, it differs from other types of supervised learning because the system isn't trained with the sample data set. It learns as we go ahead, right? And it learns and then it remembers. So you don't really have to teach again. And that's where the learning part comes in. So system learns through trial and error. It's like, again, the way we learn to ride a bicycle. Right, so we'll probably make hurt ourselves, but eventually we'll learn. And once you learn that, you will not forget how to ride a bicycle in your whole life, right? That's what they say. I think in some Bollywood movie there was this dialogue कि आदमी साइकिल चलाना और गन चलाना जिंदगी में कभी भूल नहीं सकता, something like that. So again, this is similar kind of thing, reinforcement learning. So here, when it comes to robots, they train the robots to climb stairs or to deliver packets. There are very interesting videos available on LinkedIn or internet. So they will they'll tell the robot to deliver a packet. They'll tell the drone to deliver a packet. Right, so they will do it the way a human would do, and that's exactly what the science is moving towards. Right, so then comes deep learning. Like I told you, this is artificial neural network. So here it uses neural networks in successive layers like input layer, hidden layer, and then the output layer. There could be multiple hidden layers, and every node is connected to every single node, and that's how a very complex thing goes on in there. And then eventually it gives you the output. Right, so they're especially useful if you are trying to learn patterns from unstructured data. Again, the same way, unstructured data is the Twitter data, Snapchat data, or Instagram data or so. So these complex data sets are analyzed using deep learning or neural network. Even weather forecasting, most of the models are deep learning. Image processing is coming up in a real big way. In fact, we are trying with a very interesting method where now typically if I have to develop a QSAR or quantitative structure activity relationship, so I will have molecule structure, I will have the activity, and then the software will read the structure and it will try and calculate the descriptor and calculate the relationship between the activity and the independent variables or descriptors. So here we are not using part of the molecules, we're using the whole molecule as an image and trying to analyze. So we are developing a very interesting, my collaborator is working on that. I'm just providing him the data, and when he generates some meaningful conclusions, I'm going to analyze. We've just started working on that. The guy has his own company, and then he's the same guy who went to UP and did what he did. Okay, so here, as the name indicates, neural network, so it is based on the similar concept, the way our neurons are structured or layered, and how they connect to each other and process the information. It's very interesting thing. It's complicated, but then it's very, very powerful. And so image processing or image recognition is one, speech recognition, right? And then computer vision application. So meaning computer looks at a particular image and it classifies whether it is an animal or an inanimate object, or if it is an animal, whether it is a dog, cat, shellfish, or whatever it is. All those things are possible with the help of deep learning. It's again very interesting. So if you again revisit artificial intelligence, the bigger picture, machine learning, a small part of it, deep learning, again, small part of machine learning, and data science is interspersed with deep learning, machine learning, artificial intelligence. Of course, all of these algorithms need data to work around and then eventually process it to come out with some interesting outcomes. It could be a value, it could be a pattern, it could be an anomaly, like I told you about fraud detection or so. Even the banks will give you credit cards based on your credit history. So they will analyze a very large number of parameters before somebody offers you a credit card. I mean, they'll not offer it to anybody and everybody. If the model tells you that this person is going to default, they probably will not give that person or offer the personal loan or credit card. So a lot of things goes on behind, and we can't even think about actually. So having said that, I will now get into the real stuff. There are not many slides. I mean, there are slides, but then they are very simple, not very complicated, so that you don't actually lose track of it, right? So machine learning and AI in drug discovery. So here, this is again a very interesting post. I'll share this presentation. You can read through yourself. So during pandemic, so everybody was desperately looking for drug, and that's where machine learning and AI, and even deep learning for that matter, they tried to provide solutions to find solutions to fight COVID-19. So that includes drug repurposing, that includes newer drugs, that includes also newer approaches, even for that matter, understanding which targets could be potential targets for fighting COVID-19. Very, very interesting. You can read all by yourself. Then this is another very interesting blog spot. Of course, it's a little older. I mean, this is a blog spot maintained by this guy, Simon Smith. So he talks about 230 startups using AI in drug discovery, and a lot of things are given. So this is updated. I think he updates every month or so. Now the number of startups is much higher. I haven't really checked in last few months, but then you can also look at it. So it talks about various areas in which these startups have started and contributing to drug discovery with the help of AI and machine learning. So the first, we just talk about, say, the first one, aggregate and synthesize information. Here, this is this company, 3BIGS. So it uses AI to discover relationship between diseases, targets, and drugs, and allows researchers to repurpose drugs for new indications. This is just one of the bigger picture of drug discovery. It was founded in 2017, and its headquarters is in South Korea. This is another one, Data for Cure. It uses AI to infer and organize knowledge from thousands of genomic, phenotypic, and clinical data sets. And it allows researchers to identify new targets and biomarkers, repurpose drugs, identify disease pathways which are amenable for combination therapy. It was founded in 2013 and with headquarters in California. Yes, Mohammed, you have some question? You raised a hand. You can feel free to ask. I mean, I can take the questions now or maybe at the end. Okay, I will move ahead. Then there is this another area, that is repurpose existing drug. This company called AccuraStem. It uses AI to analyze data from sources, including patient stem cells, and it allows researchers to discover drugs for neurodegenerative diseases, including amyotrophic lateral sclerosis, or ALS, founded in 2016, and again headquarters in US. This is Bioactivity Therapeutics. It uses AI to find applications for existing approved drugs. So most of these are for repurposing, and then there are many others which are which are like discovering drugs from scratch, and this is very, very interesting. But there are many companies, right? This one is Mole Inspiration. I'm sure many of you are aware. Those who are in medicinal chemistry classes, maybe your teacher might have told you. Basically, it's a simple applet. All you have to do is either draw the structure of any molecule, any chemical, small molecule, or enter the SMILES notation, and it will convert that SMILES notation into two-dimensional structure. And from that, you can calculate properties like blood-brain barrier permeation, or Lipinski's rule of 5 filter properties, or even the simple properties which can be calculated like molecular weight, molecular formula. And then it will also tell you how your molecule is going to be in terms of activity. So there is this second tab which says predict bioactivity. It can tell you whether your molecule is likely to be a GPCR ligand, or ion channel modulator, or kinase inhibitor, or kinase ligand, or it could be also nuclear receptors like PPR gamma, PPR alpha, or others. And then it also can tell you whether your compound is likely to be an enzyme ligand or so, enzyme inhibitor or so. So it tells you. So because at the back end there are a lot of machine learning models, and these machine learning models, when you draw a structure, it will compare with whatever data sets, data molecules or molecules with predicted or rather actual experimental activity are, and then it will tell you how it is going to do in terms of the bioactivity. So this is all because of machine learning. There is another one, Swiss ADME. Again, I'm sure you are using it. Swiss ADME, you just have to give the drug and it will tell you like 40 to 50 different ADME related properties or pharmacokinetic properties, and that's very, very interesting. You should try Swiss ADME for your work. Some of you may be PG students, so you can, or even UG students for that matter. Whatever drugs you are learning in medicinal chemistry, all you have to do is just go and do see the predictions and compare with the actual experimental values, and that's actually a very interesting exercise. It tells you whether your molecule is likely to be a PGP substrate or inhibitor of CYP1A1 or 3A4, 2C9, 2C19, 2D6, and you name it, and it will tell you. Even the solubility, it can predict. I mean, you all know the BCS classification, solubility, and permeability. So all of these can be predicted. Even permeability, it can predict. And so if you see that there are some issues with the solubility, you probably will not make that molecule. So your life may be easy. In one, just next to Swiss ADME, you also have this Swiss target prediction. Let me see the point. Yeah. So here you see there is the Swiss target prediction. So you draw a molecule structure, it will tell you what is likely to be the target. Again, it's a prediction. You have to take it with a pinch of salt. But then many times these things are very accurate. The predictions are quite accurate. Right. There is another one called Protox 2. Now, Protox 2 is again very interesting platform where it actually predicts the toxicity of small molecules. It will tell you what the LD50 is going to be. It will also tell you whether your compound is likely to be hepatotoxic, immunotoxic, carcinogenic, mutagenic, as well as teratogenic. And then there are at least 21 different endpoints, and also even developmental toxicities, which is very, very difficult to predict. So a very interesting tool. You should try and look at Protox 2 Protox 2 as a tool for your work. And this is where you just have to go to Google and type Protox, and it will take you to this particular thing. They have recently upgraded, and that's very interesting part. Now here, this is another one. This is commercially available software called Case Ultra. In fact, the guy who developed this is Dr. Suman Chakraborty. He's from Indore. His PhD is from Indore, SGSITS. We invited him in 2019, just before the pandemic started, 2020 actually, just before the pandemic started. So they have developed this tool called Case Ultra, which can give you a lot of toxicity endpoints. And in fact, they have developed this tool with the help of USFDA, data available from USFDA, and USFDA uses their tool for predicting, suppose a new impurity is found in a drug molecule, right? So you all are aware of NDMA impurity, N-dimethyl nitrosamine impurity, which was mutagenic, and ranitidine, famotidine were withdrawn from the market. You all are aware, I'm sure. So, so for an unknown impurity, if you want to predict, the FDA uses Case Ultra. So if the company uses this, then their life can become very, very easy. And they continuously upgrade their models and do a lot of work, and the predictions are really, really good. The interesting part is it basically tells you, it tells you what the, just a minute. This is laser pointer pen. Okay, now you see this is nimesulide, and this is the nitro group, and this one is isoniazid, which has got this NHNH2 hydrazino group. This one is cyclophosphamide. This is your NCH2CH2Cl, which is the alkylating moiety. In case of doxorubicin, you have this quinone moiety. In case of imbelin, you have this again quinone moiety. In case of etoposide, you have this. Well, I can't really see properly, but then this is the moiety which is highlighted. In case of, let's see what these are. Okay, busulfan and nitrofurantine, the furan molecule, the furan structure is what it is flagged. So basically, it will flag the part of the molecule which is likely to be responsible for the toxicity, and this is the best part, and that's why the predictions are good, and it also tells you as far as the interpretation goes, it will give you the structural alerts in your molecule. That's the best part actually. Now, similarly, you also have a BBB permeation prediction, and some molecules which are not supposed to permeate the blood-brain barrier. If they do so, then there will be CNS side effects, and some molecules which are supposed to go across the BBB, if they don't, then you will not have any activity out of that. And that's where there is a tool available, this online BBB predictor, and fantastic. All you have to do is just draw structure. It could be any molecule, it could be any chemical, any intermediate also, and you can have this BBB predictor. Basically, it will tell you, it will help you to understand the structural aspects of your molecule so that you make your designs very nice or very interesting. So likewise, there are many databases also available which will help you in predicting the toxicity properties, and this is what the distributed structure searchable toxicity database is all about. You have got chemical structure, you have got toxicity data, and then eventually they've used this for developing the models which will give you the required information from this. Basically, what they do is they have something called as ToxCast and Tox21 high throughput toxicology efforts, and that generates a lot of data, and that data is used for developing the models. You can search by the substructure, and if the substructure matches, then your compound is likely to exhibit that particular toxicity. This one is Tox21 from Broad Institute in Boston, Broad Institute of MIT. They've got this high throughput screening facility, and they do screen these molecules very fast. Now, again, the interesting part is whatever data they generate, they use it for developing the models, and this toxicity forecaster will help you in predicting the toxicity of molecules whose chemotypes are unique, and then that is the interesting part. Right. So likewise, there are many different databases like this IDA2PAM. Then there are other predictive modeling tools available. So you can just read through and get to know these tools. So at the end, at the background, it's all the machine learning tools which these algorithms and databases use, and eventually help you in predicting what you're looking for. Right. So there is another one called NIME, which is Constance Information Miner. So Constance is a place in Germany, which is like at the Germany and Switzerland border. My previous company was based in Constance. That was Takeda. When Takeda took over, it was Nycomed. So in fact, I used to go every month, like for 15 days, when I was working with Nycomed. So there is this university in Constance. University of Constance. So Nycomed funded development of NIME. It's a free tool. You can actually download NIME and use the tool. So basically, there are different modules. Different pieces which are individual programs. Suppose you want to predict something, right? So say the physicochemical properties. So then you select those modules. So first is input module. You connect it with the reader module. Then you connect it with the predictor module, and this is the output is what you give. Basically, there are these modes available. So then you select these modes, connect to each other, make the workflow, and achieve. So when the file is read by this particular, or when the data is fed by this particular node, so it will be read by this node, and then it will be processed by this node, and this node will give you the output, right? So likewise, it's like take the pieces of puzzle to make what you would want to achieve. Right, so this is a modular design, which is fantastic. Rather than having one program which will do everything right from the scratch, you mix and match. So NIME is a very fantastic tool for data sciences, including the chem informatics work. In fact, many of the Schrodinger software, those who have used Schrodinger software, molecular modeling software, many of the workflows are based on NIME. I use NIME extensively, and it's free, like I said, and then it's open source community, which basically keeps on developing these nodes. The coders, the programmers, they do that, and you can just use them, download them, use them, and achieve what you would want to do. Very, very interesting stuff, actually. Right. So the last part is probably another 6 or 7 slides, and we'll be done. ML in drug repurposing. So here, like I said, because ML can understand the patterns and analyze very complex data, So the ML as a data analysis method, so it basically leads to automated model building, and this model can be used for trying to figure out what is the second use or the other purpose of this particular.
Just a minute, I'll just mute them. I'll mute them.
Yeah. Okay, so so drug repurposing is nothing but finding new uses for old drugs, and this is where the ML can come into picture. So you analyze large amounts of data and come out with the drug repurposing hypothesis. I've already published few papers on computational drug repurposing. One is for Ebola in 2016 when Ebola outbreak happened. We actually did some computational repurposing work and eventually did publish this paper in RSC Advances, and it was fantastic. It was very well received. It was not just hypothesis. In fact, around the same time, somebody did the experimental screening of already existing drugs, and some of the drugs which we predicted to be effective against Ebola, they were indeed part of that, and this is how we could convince the editors that our paper is of value, and that was a very interesting part. So I'm talking about computational drug repurposing using the computational tools for finding the new uses for old drugs, which is the process of designing and validating automated workflows that can generate hypotheses. So you propose that this drug X is likely to be useful for SARS-CoV-2, drug Y is likely to be useful for multiple sclerosis and stuff like that. So so here the interesting part is because you're talking about already known drugs, and then you generate this computational hypothesis. Eventually, once you come up with this hypothesis, you can simply have a proof of concept by having a small focused clinical trial. And because you are dealing with a known drug, so nobody would really object to that. And by doing so, you can immediately put forth that this is going to be the drug of choice for a disease for which there is no drug. Somebody is really making noise. Yes. But anyways, a few more minutes and we'll be done. Okay. So having said that, so how, what are the steps involved in computational drug repurposing using ML? So you decide the strategy. Now there are various strategies, whether you want to use the data from transcriptomic analysis or genetics or side effects. Then next thing is you decide the approach, like which data mining approach, ML or network analysis that you want to use, and then you validate the model and then use these models for predicting. So initially you will try and predict the use the model for predicting something which is already known, and if the model does well on that, then you can use you can go to the next level and predict what you would want to use for experimental validation. In case of transcriptomic data, so all you have to do is when the say now here there is a database called CMAP. This is the again Broad Institute of MIT. It contains gene expression profile of which is generated by dosing more than 1300 compounds into one or more cell lines. Basically, you have got a cell line, say a colon cancer cell line or a colon cell line, normal cell line. You expose it to a particular drug, and then you compare with after the drug treatment. So some of the genes will overexpress, some of the genes will be they'll go down, their expression will go down. And then you compare with before the treatment or with the normal cell, and then you find out what the drug has caused, like the gene expression or the reduction. So likewise, with the help of this approach, they could identify phenoxybenzamine, which is an anti-hypertensive drug. It was identified using a disease signature derived from rat model of osteoarthritic pain, and it was then repurposed for osteoarthritis. And then, of course, it's a very toxic drug, but then they came up with this interesting hypothesis, and eventually it was repurposed. Then there is another drug, ursolic acid. It was repurposed for muscle weight loss. Again, both of these were the success stories. There are many others. These are just two using transcriptomic computational drug repurposing. There is another one side effect. So we all know that every drug on an average has 70 different side effects, and these side effects will stem from the interaction of the small molecule drugs with unknown targets or off targets. And that's where, but then if you analyze these side effect profiles, you can essentially get to a very interesting outcome, and that's where you can repurpose some of these drugs for unknown indication, unknown as in for indication there for which there is no drug. So sildenafil or Viagra is very nice example of side effects. But of course, I'm talking about the use of side effects data for predicting the new uses for old drugs using the computational methods. And since you are dealing with the already approved drug, so there is no issues with the translations. You can directly test it. In fact, there are many drugs which are used in so-called off-label, indicated in off-label uses. Metformin, which is a very powerful antidiabetic drug, is used also for anti-cancer indication. A lot of oncologists prescribe it because, again, it's a safe drug and it has a very powerful anti-cancer effect. Right? So they have identified using a similar data. There are likewise many examples. Then there is another approach for genetics. So here you try and look for connection of specific genes to specific human diseases. And then nowadays it is possible to sequence the genome with the help of NGS tools or next generation sequencing tools. So somebody has identified a gene called NTE5, which encodes for an enzyme involved in adenosine metabolism, which is linked to a dominant and adult onset arterial calcification, which ultimately leads to the cardiovascular disorders such as atherosclerosis and further complications. So here they actually found out that dipyridamole, which is an anticoagulant drug, they actually proposed it for the treatment of this unique disease or rare disease, which leads to arterial calcification via this gene. So again, this is just one example. There are plenty of such examples. So having said that, there are other methods where you analyze the pathways and networks to find out whether we can repurpose some of the known drugs for getting to a particular indications of target effects. There is this drug, PD drug, encapone. It was then looked for, it was tried for its antimicrobial or anti-TB activity. Then you can also use molecular docking, the regular molecular docking, or there is something called as reverse docking. So likewise, they have found out haloperidol, which is an antipsychotic drug, as a lead anti-HIV compound. So plenty of examples. And at the base of many of these computational drug repurposing is ML or AI, mostly ML actually, ML or deep learning. So if you have a small molecule drug, how will you computationally repurpose it? So you can either use a structure-based approach, you can use a ligand-based approach, or you can use a combination of these. And now in case of structure-based approach, you try and predict the target using say Swiss target prediction. Ligand-based approach could be QSAR or pharmacophore-based approach. You can use both and then find out what is the likely to be, how this molecule is likely to be useful for another indication, that is drug repurposing, which is very, very powerful. So there are hundreds of examples, successful examples of use of ML in drug repurposing, and then sky is the limit. In fact, the other day I spoke about the use of ML in QBD for biopharmaceutical production. So I delivered a lecture in RC Patel, Shirpur. So I spoke about use of artificial intelligence for biopharmaceutical manufacturing, like antibody manufacturing, where they use QBD or quality by design, where DOE, that is design of experiments, is an integral part, where you try and there are multiple factors which can affect the dependent variable. It could be product yield, it could be the product stability or instability for that matter. So with the help of ML, you can find out those so-called critical process parameters as well as the critical quality attributes, and then use the ML to further fine-tune the biopharmaceutical manufacturing to come out with a good product and eventually a stable one without getting into too much of I would say trial and error, because as opposed to small molecule manufacturing, the biologics manufacturing is very, very, very complicated. And this is where the ML or AI tools can be particularly useful. And with this, I would like to stop. Thank you so much for patient listening. And if there are any questions, I would love to answer your questions. So exactly, yeah, little less, a little over 1 hour, but yeah.
No issue, no issue. I think the more information that you have given, it will help the researcher in finding out the best techniques to use various modules as explained by you in repurposing, as well as to know about the toxicity, which is very important nowadays, because if we can do with machine learning, we know the targets which will cause side effects. That will be very helpful for the researchers. And I'm glad that most of our researchers over here who have joined us in this session, and I think that it will help them in finding out the best tools for predicting the.
There are many primers, or I would say certificate courses, where you can start, understand, and then eventually, and even the tools, they are freely available. All you have to do is just learn and download those tools, start working, process the data, and just get an expert in that.
Prashant, I just wanted to request you something. Can you just put up the websites that you have put it in the presentations? Can you just give us one thing, so that I think there was one query regarding the books and sites.
Yeah, I will share the presentation. In fact, I have other websites. I'll compile them and I'll share with you. You can just
we will do that, because I think there are many queries about that, so that we can help them out, so that it will help the researchers. Rather than going haywire, doing a random search, they will get a precise search.
Yes. So what I will do is I'll put all the books which I have maybe in one folder, and I'll share that folder with you. Then you can just circulate.
Yeah, sure. Thank you.
These are freely available books from the internet.
Good evening, the participants, and I would be glad if you ask some of your queries. Yeah, we have put down in the chat box, Prashant. If you can there are some queries, I think, in the chat box also. You can.
Yeah. I will just read through. One is, of course, Dr. Sridevi. She says, nice presentation and good application in determining toxicity and other properties of the molecules. Then MI can be used in formulation and in fact, this is in fact a very interesting application. We have in fact last week we have applied for a project we have submitted a project to CRG, Dr. Padma Devarajan and me. So one monoclonal antibody. So she's going to make a formulation out of that one monoclonal antibody. And I'm going to help with the help of computational tools. I'm going to help her in identifying the right excipients who would be helpful in stabilizing the formulation. So yes, people do use AI or rather ML for getting the right combination of excipients. Of course, like I told you, the use of QBD and DOE for biologics manufacturing, AI is part of it. The same thing can also be extended. I mean, people have also looked at the manufacturing of small molecule, rather the formulation of small molecule drugs from the QBD perspective, and ML is used for identifying those CQAs and CPPs, and then the relationship between them, and optimizing the formulation with minimal efforts, minimal experiments. Yes, it can be used, definitely.
Yeah, I would like to have some vocal conversation rather than this thing, so that we can have the person. So I request them to come out and talk. Yeah, there is something called we are using DOE.
We are using DOE. Yes. In fact, what I will do, Pramod, I'll share my presentation on the one which I gave at Shirpur on the use of machine learning in the QBD for biologics manufacturing. So very interesting papers, and that will definitely help the participants who are interested in this subject to learn more.
Thank you, Prashant.
Yeah, no problem.
queries, anything that would like
Any
to
other question or so?
queries you would like to ask Dr. Prashant? I
Dr.
think he has,
Prashant.
yeah.
Hello. Dr. Prashant.
Yes, hi.
Yeah, hi, I'm Prakash. We have some B Pharma students in this meeting, like
Okay.
in this webinar. How you going to convey this artificial intelligence or like machine learning? How they will going to in future? What they will in this presentation? What they understand? Maybe their level it's a little difficult, but how you going to convey for them?
Yeah, that's what I said. There are some very interesting websites dedicated for learning. Now, what I would say, like I said, the AI is a little complicated, like it's the higher end or advanced version, but students can start with the machine learning algorithms. Again, like I said, if you use Python or even R for that matter, the code is like as if you are, like two people are talking and you're writing a statement. So just like that, you tell the software to execute. Of course, there is a syntax, but it's not as complicated as say first level or second level languages. This is a fourth level language or fourth. Yeah, the language is very simple. Python is pretty easy to follow. And so this is where these softwares or rather these tools or these websites, they will take you from a point where you don't know anything to a point where you know substantial thing, and then you can build on that. So then you can get into more advanced courses. I will recommend some interesting tools as well as web pages. In this IBM book, which I have mentioned, once they read, I think it's 40 pages, if I'm not, if I recollect it, 40 or less than 100 pages for sure. So once they read through, as long as they know how to use Microsoft Excel, believe me, many of these things will be pretty clear to them, how to work with the data and how to like how to use the data as an input for a machine learning algorithm, and what to make out of what we basically do, meaning predicting something or calculating some quantity. It could be a ranking, it could be some actual prediction of a number, or it could be a binary yes or no type prediction. A lot of things are possible. And many of the tools, the one which we use, the linear regression or logistic regression, decision trees, those are like simple tools. So if they have learned about statistics, then it becomes easy for them to follow these tools as well. So statistics and a bit of, I would say, Excel, once they know how to use it, and it becomes easy to build. And these softwares or web pages will definitely help them in building these competencies, and they should do it. I mean, now that they are a BPharm student, so they have a greater capacity to learn compared to people of my age. Like as we age, our capacity decreases, but students, these are smart students. They will grasp just like that.
There is a feedback form in this thing. So I request all of you to fill the feedback form, and then we'll be providing you with the e-certificate for attending this program. Please do fill it. Yeah, I got some, I was just going through some of this thing, chat, this thing, that got a good feedback from everyone. I hope people have learned something today. And since being a new topic for most of them, I think artificial intelligence, what we say, that many things has well explained by that. He knows what I'm going to purchase the next thing. If I log in through Amazon, next time they'll say, oh, this thing is what you're looking out for. So so they know everything through
they know everything.
Yeah, they know everything. So
yes.
Yeah, that will help us in future. It's to be used in the right direction. That's more important.
Yes. So I mean, I did not want to make it too complicated, because otherwise, students would lose interest. But use this as a primer to really build onto these competencies. I did in my previous organization. So I did 3 certificate courses. Certificate as in that was there's a company called SAS, and they've got around 200 modules, out of which I learned the basic programming module, then visual analytics, and then predictive modeling. And that's exactly how I got into this. So I'm a formally trained data scientist who has interest in data sciences as well as machine learning. I don't say I do AI, but I do ML. So I'm at the lower end of this, but then as far as my applications go, I can very well use it, and that's exactly how I can actually expand my capabilities. As in, believe me, sky is the limit, and you get to these competencies, you develop these competencies, and that can take you to a new height in your professional career, whatever you are dreaming of. Believe me, it's really wonderful. Sooner or later, you will have to learn this. So why not today? Okay. I'll get you some interesting material.
And we'll be
to
sharing
read.
the YouTube link,
Presentation.
because YouTube link is there of the entire program.
Yes.
So we can share it. So whatever information, you can just go through that. We'll be sharing it on there is one common YouTube channel.
Yes.
So you can, whatever things you want, you can just go through this YouTube link.
Yes,
We'll be sharing
yes,
about this. So
Perfect,
you can
perfect.
always refer when for any information.
Yes.
Any more questions? I think there are very few people who come about, talk about, want to express. If you are finding it difficult to talk, I think I request you to put it on the chat box so that we can ask the question to Dr. Prashant. I know there will be a lot of queries because this is a new topic.
Yes, case studies. Yes. In fact, yes, that's exactly what these softwares do, or these web pages do. They build the competency using small examples. So in fact, right away when you start taking that, say, 7-module course, again, it's like you do at your pace. So right from the first module, you are actually typing some code. Simple one, which will guide you what is, if you're making a mistake, it will tell you a few basic things, then you do that and you execute it, and then you will feel happy. Oh, you have actually written one line of code, it was executed, it gave you the output, and that's how it gets you more and more interested, and that's how you learn. It basically builds your competence. So yes, yes, the case studies, they are wonderful. In fact, towards the end, like 6th or 7th module, you basically work with the data, real life data, and you develop a small model out of which and use it for prediction. Very interesting ones, actually.
Please do share that module.
Yes, I will.
Yeah, so that we can share it. Those who are interested can really pursue with that.
Yes. Sure. I'm very happy the students, many are students here, and then there are researchers as well. And like I said, those who are really interested, they came and attended this lecture on a Sunday afternoon. So I'm so sorry for giving this time, but then it's not, I was occupied with other things. And that's exactly why. So yeah, thank you so much.
It's our pleasure, Dr. Prashant, to listen to you. And I think so it will motivate people in the right direction so that they can use the tools, whatever you explained today, in their research and in their future endeavors, wherever they are. So knowing about, if you know the ADME toxicity, because that helps them see whether you are in the right direction or not, or you have just lost your time. So if you are structured, as you said, many of the softwares where it predicts the toxicity and the site of toxicity.
Yes.
That's very much important. Oh, so no, you know that this is some problematic area, I can modify it.
Yes.
That helps a medicinal chemist in a most probable way in designing a better molecule.
Yes, that's actually very, very important.
And I'm glad that when we are in Piramal together, we used to have a lot of chat.
Yes.
So our both labs were in front.
Next to each other.
Next to each other, because we used to discuss a lot about mechanics, mechanistic approach during our drug design program and all. So it was nice experience with Dr. Prashant, sharing knowledge, gaining knowledge. So it was, as always we say, knowledge has to be shared to gain more.
Yes.
So I think that's the module that we work on, because no knowledge is of use if it is only kept to yourself.
Yes.
So I believe in a mode that share, and because you put a stamp that I know this, you're perfect in that. So unless and until you share, there is somebody to tell, okay, there is something wrong. That means you think that everything is right as per it's your perspective. So I request everybody, come and share your knowledge. So that's the best way where you improve on your knowledge. You just keep it to yourself. It is only for you. Nobody else knows. So be open up, because research is where a field where you might think that is right, but there is somebody else who will tell you the right way to do it. So express your knowledge, share your knowledge. I think that will boost everybody's work. And in this present world of technology, information spreads very fast, because since I'm pursuing my PhD right now, I know how important the data is, how you sit and with the network of people. Okay, I want something, I just put down to some people. Okay, can I get an help? Yeah, you get it. So be open, be free to ask me anything. I'm telling you, with this foundation, I tried to help out to reach out to many people with any resources, because through the contacts that I have, and I know people are good enough to help each other.
Yes.
So be free to ask and communicate. It's the most important thing. Communication is one of the most important thing in present day. If you don't communicate, nobody knows what's there with you. So please do communicate. I'm glad to tell you all that, Prashant, that I've gone for last 3 days. I was in Bangalore for an NSS camp.
Yes.
And we have been, our college has been selected for an UNSF program. So yeah, and that will help. And I'm glad to my volunteers of Aloka who are the part of this NSS team.
I just love them. I mean, I see them. Believe me, I mean, when I get a chance to meet them,
yeah, I'll do invite you if possible. I'll do invite you to our to Mangalore. Anyway, my house is open to you. Anytime.
Of course.
You can.
I actually would want to be part of some of these activities, as in actually going out with these participants with you and take part in some activity. Visit to some ashram or anything.
Because we are planning on. I'm just going to sit down with my volunteers. I'm going to plan on malnutrition and immunization, which is a program.
Okay.
So I'm just talking to some of the block level workers. Today I just had a few talk with some of the people over here. I'm thankful to Dr. Prakash. He is the principal of one of the colleges in Tumkur.
Oh.
Yeah. So, and he encouraged students to come, and that's the most important from the principal point of view, that he encourages students to be a part.
Yes.
Students
Thank you for this organization also. I'm really happy to you are taking care about the students and researchers also.
Thank you, sir. Thank you, sir, for sparing your time. I think you are also busy with a lot of your works, and Sunday afternoon coming down to this program and encouraging students. I want more and more people to encourage students to be a part of this webinar series. And I'm glad that Mr. Mohammed Sheikh is there over here. Mohammed, sir, are you there? Mohammed Sheikh. I think that our next speaker will be Mohammed Sheikh, Dr. Mohammed Sheikh from WOCAD Research Center.
Oh, okay. Wow. Perfect.
Yeah, he's also my ex-colleague from WOCAD. I've worked in some of
yes, I remember.
Yeah, because he's one of the most wonderful person. He also delivers a lot of lectures for the different colleges, universities, and I'm glad that if everything finalizes, next week Dr. Mohammed will be speaking on a new topic, which will be beneficial for the students. I was just having confirmation with him. So we'll be putting on soon the topic once we get the confirmation. Yeah, it's almost done. And I'll try to get in more people where the students will be benefited and the researchers will be benefited. So that's the basic idea of that. We have started this webinar series to reach out to people so that they get knowledge. See, half knowledge from a technical person, if you get a knowledge, that improves your confidence rather than just Google searching and you don't know what to do.
Yes.
When you have when there is a path, there will be so many sideways, but you should know in which path you are to. And that's the way where we are trying from Aloka through this webinar, so that we show a path to the people and which will help them in their future endeavors. And I would really thank Dr. Prashant and wish him many, many happy returns of the day and the best he gets in his entire career and his life. And I'm thankful and I give my regards to all your family members. I don't know. I think Milind was also there, Rode. I think you might be knowing Milind.
Yes.
Yeah. So yeah, I'll do share the slides with you, sir. So
Perfect.
I'm thankful to all the participants who have been the part. I tell you, Dr. Suvana Kini, she was there. She was my guide for MPharm. Dr. Gautam Shenai, he's also a guide in our Manipal College of Pharmacy, MCOPS. And there are many more people. Prakash sir, and he's wishing you on your birthday.
Yes.
There are many people who have joined this session. Sridevi, our
Yes,
ex-colleague
Yes.
from Piramal. Last time we had Kishore Kadam.
Oh, okay.
So it was nice when we meet our colleagues. I've tried to reach out to many people so that they join us, be a part of this session. And I'm glad that people are joining. Yeah, it will increase as the days progress.
Yes, definitely.
And when people come to know, they will surely join us. And we will create some awareness to you.
Indeed.
And now I think if there is no further questions, I would like to request our volunteer Neeta to deliver the vote of thanks. Thank you.
Thank you.
Over to you.
For me, every hour is grace, and I feel gratitude in my heart each time I can meet someone and look at his or her smile. I would maintain that thanks are the highest form of thought, and that gratitude is happiness doubled by wonder. As we come to the end of today's session, on behalf of Aloka Foundation Bangalore, I deem the honor and privilege to deliver the vote of thanks. Let me first start by showing my sincere appreciation to our guest speaker for today, Dr. Prashant Kakar, sir, for taking out time off his busy schedule to take up an important session today. I'm sure that we all have a better understanding about the topic now. Thank you once again, sir. I would also like to thank Mr. Pramod Kumar, President of Aloka Foundation Bangalore, for the constant support and guidance throughout the event. I owe special gratitude to all the members of the foundation for their time and effort in conducting an event. Lastly, I would like to extend a big thank you to all the participants who have attended today's webinar, without whom the success of this webinar was not possible. Thank you, all of you. Once again, we wish you a very happy birthday, sir.
Thank you so much. Thank you so much.
And Prashant, there is one more thing I would like to tell. Today is the birth anniversary of the Manipal University founder. So it's a great, you share a birthday with some of the noble people in this.
Yes. Thank you so much. Thank you so much.
Yeah. So TMA Pisces, Gautam Shena sir has 30, April 30th is the birthday of TMA Pisces. So with this, I would like to end the session. I would like to thank everyone. I'd like to thank everyone who have taken this their time out to attend this session and show their support to Aloka Foundation in their various endeavors. So with this, I would like to end the session and thank Dr. Prashant for a wonderful session, an inspiring session, and a knowledgeable session. You'll be receiving your certificates in a day or two, and please do fill the feedback form. That means a lot so that we know how well we can do it the next time. So your feedbacks are most welcomed. It's shared in this link. So do fill the feedback forms and we will get back to you with your certificate duly signed by Dr. Prashant Kharkar. And thank you for attending the session. Thank you once again. With this, I would like to end this session. Thank you. Good day. Have a nice day.
Bye-bye.
Thank you. Thank you. Thank you, Prashant.